Welcome to my channel, The Science Academy. I am Narayan Chandra Mozumdar, lecturer in physics, Rajuk Uttara Model College, Uttara Model Town, Uttara. Today's learning outcomes. After ending the lecture, you will come to know the brief discussion on projectile motion, how to solve mathematical problems on projectile motion, practice mathematical problem. Now, I have discussed about projectile motion in my previous lecture. Now, regarding the projectile motion, I will discuss in briefly the law of compound motion. When an object is moving in multiple direction, the motion in one dimension has no effect on motion in another dimension. Very important things. Think that the body is thrown in this way, so it will go in this path. So it has, in my previous lecture I have discussed that it has it has two part of everything. That means if it has position vector, so it has two types of position, two component of position vector, that is, this is the x component and this is the y component, and it has also velocity. When velocity this is the ground, and think that after sometimes the body reaches here, the velocity of the body is the tangent, so this is the velocity, and it has two part. One is horizontal part, that is Vx, and another is vertical part, that is Vy. The main thing is that the Vx is not influenced by Vy. Similarly, acceleration Ax is not influenced by Ay. So completely different, completely independent to each other. So when you calculate the horizontal distance, think then distance horizontal, then s equal to ut plus half at square, you have to take the equation. So when you calculate the horizontal distance, you will put the value of u along x-axis, that is Vx naught t plus half a x component t square. So what is the value of Vx naught? In my previous class I have lectured, that is the V naught cos theta naught into t, but this part is 0, the part is 0, so that is V naught cos theta naught into t. So here this x is completely different from the, but when you find the distance in y axis, so y will be Vy naught t and minus half gt square. So the value of y naught, you know, V naught sin theta naught t minus half gt square. So that is the motion The motion in one dimension has no effect on motion in another dimension. You can see the picture, the animation, that is Vx is not changing. Here Vx is not changing. It is always remain 60 meter per second. But velocity, the component of y is changing. That is Vx is not completely different from the Vy. Horizontal velocity is maintained by inertia. Another thing, when you throw any ball, so horizontal motion, it has two parts, horizontal and vertical, but this horizontal motion is maintained by its inertia. Equal distance traveled during each second and constant velocity. That is the along x-axis, along the horizontal, the velocity remain constant. Equal distance, you can see the picture, equal distance in equal time. That is horizontal distance, horizontal velocity is constant velocity. Vertical velocity increases each second with pull of gravity in free ball. Look at the picture. Velocity is increasing, velocity increasing. So each second the ball goes 10 meter per second. It is 9.8 meter, but here you think that 10 meter, 9.8 is near about 10 meter per second. So in every second the velocity increases by 10 meter per second. So first of all, the velocity, after 1 second the velocity of 10 meter per second. After 2 seconds the velocity is 20 meter per second. After 3 seconds the velocity becomes 30 meter per second. After 4 seconds the velocity becomes 40 meter per second. So in every second the velocity is increasing. So the projectile motion, vertical velocity increases each second, but no vertical velocity increases, but horizontal velocity does not change. That is the motion. You can see the increase of velocity. This is the horizontal component, horizontal component, horizontal component, horizontal component of the velocity. But increasing, velocity increasing, vertical component is increasing. The path is not a straight line. The path is trajectory. This is the path of the motion. When projectiles are launched at an angle, the initial velocity has a horizontal and a vertical component. I have found that is Vx naught equal to V naught cos theta naught and Vy naught equal to V naught sin theta naught. That was the initial velocity. The path of the cannonball is the shape of a parabola. The dimension of the parabola are determined by the magnitude of Vx and Vy components. There is a parabolic path, Vx, Vy. If the angle of launch is high, the velocity Vy component is more than the Vx. In that case, the cannonball goes higher in the air but does not go as far. If the angle of launch is low, velocity Vx is much greater than velocity Vy. The cannonball goes further but does not go as high. What equations we use? Look at the, for x-axis, the s equal, that is s equal to ut plus half at square. So when you take x-axis, then this u will be component of initial velocity along x-axis, and there is no acceleration along x-axis. And also acceleration becomes 0. So main thing you need to understand, you need to remember, that is when you determine anything along y-axis, then other component should be xy component. Think that you want to find the Vy. So using v equal to u plus at, you can find also Vy. So the Vy, so what is the component of uy plus ay into t? So what is the uy? It is written in your book, that is y v y naught, that is v naught sin theta naught minus gt, because ay is minus t minus g. Example, the following figure shows an aeroplane, that is the aeroplane. The initial velocity was 150 meter per second, that is the horizontal velocity. It drops a body, and the body will go in this path. The following figure shows an aeroplane moving horizontally with a constant velocity of 115 meter per second at an altitude of 1050 meters. The plane releases a care package that falls to the ground along a curved trajectory. Ignoring air resistance, determine the time required for the package to hit the ground. How far east the package travels during its fall. So that is the object, that is the relief care package. It is dropped. So since the aeroplane was in this velocity, that's why the package also has this velocity due to inertia of motion. Since it was the plane was moving with velocity 115 meter per second, that's why the package dropping from the aeroplane also has this velocity due to inertia of motion. So it will fall down just like this path. So you have to determine what is the time needed, and height is given here, and what is the horizontal distance also. So determine the time is taken for the care package to hit the ground. So in which component unit you have given this distance? You are given only this instruction, the height y. So when you want to get the information s equal to ut plus half at square, so then you have to write s equal to ut plus half at square. So this is y equal to v naught sin theta naught t minus half zt square, since it is y. So the value of y is minus because it is downward distance. That's why that will be minus 1000, 1500, 1050, and v naught. The value of v naught is 115 sin 0 degree, sin 0, because it is making angle 0 degree with the horizontal, sin 0 degree into t minus half zt square, half gt square. So finally what will be the equation? That is y equal to half gt square minus y equal to minus half zt square. So minus 1050 equal to minus half 9.8 into t square. From this equation you can get the time. So and this time, when you get the time, you can find the horizontal distance x equal to v naught cos theta naught t. So using this time you can get the horizontal distance. So thank you so much.